Okay, you're a gas pressure. Some key things that I want you to try and understand here. Let's take a balloon as our example. We inflate a balloon, okay, and when we do that, we push air inside. And I want you to think about the behaviour of air particles. Air particles are far apart from each other and they move fast. Okay, so we can show this with arrows to show that they are moving fast. Now, to create pressure, these particles moving fast inside the balloon will hit the the inside surface of the balloon, and they push it outwards. Okay, so that creates a pressure inside. The reason the balloon stays at that size is because the air particles outside, which we'll just show in red, are also pushing back in, and the two pressures equalise. So the force pushing outwards from those particles inside, hitting the inside of the balloon, is equalled by the pressure from the particles, gas particles, outside, pushing the balloon back in. Okay, so the balloon stays the same size. Now we can change the size of the balloon by doing different things. We can increase the volume of air. So by doing that, we've now got more gas particles in the balloon, so there is more force pushing outwards. Okay, so these particles are pushing out with greater force, so they make the balloon bigger. And eventually, the force of pressure from particles on the outside will equal it, and the balloon will stop getting bigger. It will stay the same size. It's bigger than this one because the pressure inside was greater, but now it's equalled by the pressure of the gas on the outside. So there are two forces acting, one trying to push out, making the balloon bigger, and one pushing it back in, which is now keeping it at a steady size. Now, other things we can do here. If we heat up the gas inside the balloon, what we do here is make these particles move faster. So if you go back to your year 7 particle theory work, what happens is the particles themselves do not change size. They don't get bigger. What they do is they move faster. Because they're moving faster, they're pushing the balloon outwards with much greater force. So they are whizzing around really fast now, and huge amount of pressure, making that balloon bigger. Okay, you've still got the same pressure on the outside pushing in, so the balloon will eventually reach a bigger size but stop getting bigger. Okay, so we've heated up the gas particles on the inside, they move faster, so they hit the inside wall of the balloon with greater force, which increases the pressure inside, and that is eventually equalled by the pressure on the outside. Balloon gets bigger but then stays at that bigger size. Okay? We can make the balloon smaller if we cool it down. If we cool the gas down inside, and I've made this balloon far too small, so my particles are going to look slightly different. Maybe not. They're moving much more slowly now. So they move more slowly. So they hit the inside walls with less force. So the pressure in here is going to be lower. Okay, so you use the reverse argument here, where particles move faster, greater force of impact on the inside, so therefore greater pressure. That makes the balloon bigger, Cooling it down makes the balloon smaller. Now you can try this by putting a balloon in a fridge or a freezer, and you'll notice it gets much smaller. Okay, quick demonstration here of gas pressure. I've got some hot water here, which I'm going to add to this bottle, and the dogs are singing for our benefit while we do this. Now just put the lid on quickly and give it a shake. Now that's going to heat up all the air inside, okay? It also pushes the bottle out because the gas pressure inside, listen, you can hear the gas escaping. Okay, so now that gas has escaped. Swish it around a bit more and put the lid back on. And now I'm going to put it in this container of cold water. Okay, now as soon as I do that, oh, the dogs are still singing. We are going to see the bottle starts to collapse inwards as that gas inside starts to cool down, and that's because it contracts. Can you see that? So as the gas inside contracts and the particles of the gas get closer together, the pressure on the outside of the bottle is greater than the pressure on the inside of the bottle, because the gas particles inside are getting closer together. So you can see the whole thing has collapsed down. So let's explain what happened in the demonstration. First step, we put really hot water inside the plastic bottle. That hot water causes the air inside to get really hot, and those particles start moving very fast, which causes the air to rush out. Not all of it, but some of it. So some of that air is rushed out, and the particles of air on the inside are moving very fast with a lot of pressure being exerted. Okay. Now, when we cool the whole thing down and we put it into that container of cold water, then the gas particles on the inside start to cool down. We put the lid on it, so the air can't get in and out, and eventually these gas particles start to slow down and they exert less pressure. Now remember, there is also going to be particles which are exerting the pressure from the outside. So these are normal particles which are impacting on the outside wall, and they're trying to push inwards and make the bottle smaller. The particles on the inside are pushing outwards, and they're trying to make the bottle bigger. While these are moving fast, when they're hot, the two forces are equal and the bottle stays the same size. As soon as these start to cool down, they move more slowly, or more singing, and the pressure they exert is going to be much less. So what does that do to our bottle? Oh, lots of singing. What does it do to the bottle? It causes our bottle to collapse inwards. And it collapses inwards, okay? Because the pressure on the outside is bigger than the pressure on the inside now, because these have cooled down, they're moving more slowly, so the pressure inside is lower, the pressure outside is greater, so the whole thing collapses down.